Hey guys, today we're going to start looking at Unit 4 and talking about the unit circle, but before we do that, we have to be able to identify a new way to measure angles, and that is using the radian. In ancient Babylonian times, the Babylonians measured things in a lot of base 60, so we even use some of it today. So for example, that is the reason there are 60 seconds in a minute and 60 minutes in an hour, and so on and so forth. And so one of the other pieces that we inherited was that the Babylonians decided there would be 360 degrees in a circle. The problem with that is that it's completely arbitrary. It's just a matter of taste, like that's where it came from. And so throughout time and many mathematicians have come up with another way to measure angles, and it actually is dependent on a circle. That is a radian. So basically, a radian comes from this. So if you have a radius of a circle, so let's say, whoops, from here to here, right? That is your radius. And so what mathematicians have done is they have said, hey, the length of this radius, well, I'm going to go that length around the outside of my circle, approximately. Mine's not going to be perfect. And I'm going to say that that is that measurement that makes, we'll call that 1 radian. Beautiful. So the formal definition of it, and you can write this part down, is a unit of angle measurement equal to the angle formed around the center of a circle with arc length that is the radius of the circle. So this length right here and this length right here are the same, it's just that this one's curved and this one's straight. And so then that angle formed in the middle is 1 radian. And now we're going to be looking at how to change the fact that we have 1 radian measurement of a circle and how that looks with degrees and back and forth like that, because the same way that we know how to measure distance in different ways, so like kilometers, meters, centimeters, feet, miles, yards, right? We have to be able to convert back and forth between all the different ways that we measure distance. That we have to also be able to convert between measuring in degrees and radians. And so some helpful things to know, thinking about that, is that we know that there are 360 degrees in a circle, and we know that the circumference of a circle is equal to 2 pi r. So if we take the most basic circle, the unit circle actually, and we make our radius 1, that we can set up a proportion between radians and degrees, so that there are 360 degrees in 2 pi radians, or rad. And then if we reduce that even farther, there are 180 degrees in just pi radians. When you use degree measurements, it's important to use the degree symbol notation. A lot of times though, you will see the radians without any units on that. And that's because when you use pi in angle measurements, it's basically the implication is that you're measuring it in radians. So you don't necessarily need to write rad or radians if there's pi's in your answer. Okay. So let's go ahead and work on converting some things. So if we are going to convert radians to degrees, basically you need to multiply your number of radians by this conversion factor, this 180 over pi, but you have to make sure that whatever you're trying to get rid of goes in the bottom. So since we're trying to get rid of radians here, we need to put the radian piece in the denominator. So 180 degrees will go on top, and pi radians will go in the bottom. And so we're going to go ahead and do that. Multiply this by 180 over pi. What's nice about this is that your pi's cancel. And so then really in your calculator, you're just going to do 7 times 180 divided by 6, because 7 times 180 divided by 6. You could also do the 7 divided by 6 part first. It doesn't really matter to me. I usually like to work across the top and then down. And when we do that, if I do 7 times 180 divided by 6, I end up with 210 degrees. So the radian measurement, 7 pi over 6, is the same thing as 210 degrees. All right, we can do the same thing here. It might freak us out a little bit to see a negative, but that's okay. You don't do it. Don't freak out. 180 over pi, because I need to get rid of the radians. So I can go ahead and cancel out those pi's. And I can do in my calculator negative 15 times 180 divided by 4. Negative 15 times 180 divided by 4 gives me negative 675 degrees. So that is the same angle measurement as this one. All right, and then this one we'll do 4.5 radians. Notice for this one you had to actually write radians because 4.5 doesn't have a pi in it, so it's not implied. And so this is still in radians, though, that's what it tells me. So if I want to convert it to degrees, I multiply it by 180 over pi. Now, unfortunately, in this problem, pi's don't cancel, and so I actually am just going to have to go ahead and calculate all this stuff all at once. So you can do in your calculator, you can do 4.5 times 180 divided by pi. So I'll do 4.5 times 180 divided by pi, and I get 257.831 degrees. Ugh, that one isn't nearly as pretty. Oops. When there isn't pi in your radians, it doesn't usually come out very nicely, because my pi couldn't cancel. So I believe that in some of the assignments that you'll be asked to do, just make sure that you round appropriately. So I usually round to 3 decimal places. Some questions might only ask you to round to the 10th place, which is the 1 decimal place, or the 100th, which is the 2nd. So just look out for that. But that's how you convert from radians to degrees. Now, when we go the other way, converting from degrees to radians, you multiply by the same conversion factor, but this time we want to get rid of the degrees, so your pi goes on top because we want it to become radians, and we need to get rid of, wow, maybe I could write appropriately. There we go, 180 degrees on the bottom. So I'm going to go ahead and do that. Pi over 180 degrees. Now, you'll notice that this one, we don't have any pi's that cancel at all, right? It's just like not going to be a very pretty number, and you'll notice that with a lot of our radian measures that we started off with, we had some very pretty exact radian measurements. And so how we deal with that is we don't put pi into our calculator if we're converting to radians. We want our radians to have pi in the answer. So what you're technically going to do is you're just going to do pi, it's just going to be there, and then we just figure out what the reduced fraction is of 120 over 180. So in my calculator, I'm going to go ahead and do 120 divided by 180. That will get me an answer. So let's do that. 120 divided by 180. And that gets me a really gross decimal answer. And so what I want to do is I want to change that back to a fraction. So in your calculator, if you hit math, enter, enter, after you get this answer, it's going to go ahead and give you the most reduced form of this fraction, but it will be exact. It won't be like a decimal that repeats for forever. So now I got my answer. I hit math, enter, enter, and it gives me 2 over 3. 2 over 3. So this is the exact radian measurement of 120 degrees. It's much prettier looking than this. All right, so we're going to do the same thing with this next problem. So negative 740 times pi over 180. I'm going to go ahead and just leave the pi. And in my calculator, I'm going to do negative 740 divided by 180. And then I'm going to hit math, enter, enter. So negative 740 divided by 180. Yep, that's a gross decimal. Math, enter, enter. Ooh, negative 37 over 9. So that's my exact radian measurement. All right, last one. Pi over 180 degrees. So my pi is just going to hang out. And then 30 divided by 180. Math, enter, enter, gives me pi, 1 pi over 6, or just pi over 6, because who writes 1 in front of anything? And that's how you convert from radians to degrees, and from degrees to radians. All right, let me know if you have any questions.